proper uses of a separatory funnel. Traditionally, after a chemical reaction is carried out, we have to first isolate our material and then go about purifying our material. What we have here is a solution of diethyl ether. We have stir bar as if we had done a reaction, and I've added a compound called benzophenone just to illustrate the solvent-solvent extraction, and then later we're going to show how to do drying and rotavap and isolation of your product. So in my round bottom flask I have approximately 1 to 2 grams of benzophenone, a stir bar, and about 50 to 60 mils of diethyl ether. To do a solvent-solvent extraction, what we're going to do is take advantage of the fact that our material here is soluble in an organic solvent, but there may be other materials that we want to isolate. Perhaps there's some salts left over from the reaction which are water soluble, and we would like to remove them from that solution. We'll be using a separatory funnel. This will hold about approximately 125 mils of solution. It has a stopcock valve. It's closed in the horizontal position. We do have an appropriate clamp for this. It's called a split ring clamp, and it works as such. Now, to begin the process, I need to put my organic material in here, ensuring that the valve is closed and the nut on the end of the valve is firm. It does take a little bit of effort to rotate the valve, but it's nice and securely closed. Transfer the solution. Again, funnels aren't necessarily required here. Some care must be used to avoid transferring the stir bar. I want to make sure that our transfer is complete, so I'm going to use a little bit of fresh diethyl ether, approximately 10 mils. Rinses and pour and transfer our solution. For demonstrative purposes, I'll just do this twice, but again, 3 being the magic number. Ensure that the material is transferred completely. Now, in this example, we're assuming that we have some unreacted starting material, perhaps some water-soluble components, salts and the like, and we want to remove them from our solution and just isolate our organic material. So what we do is we add some deionized water, 15 to 20 mils. It's just an approximation, it need not be measured. Now I hope the camera can show this. We've got 2 distinct layers present. We have the dense water layer and the light organic layer. Now we're going to get an opportunity to mix these 2 solutions within the separatory funnel, but the idea being is if we have impurities, salts, etc. in the organic solution, by letting it come in contact with the aqueous solution, we'll extract or wash out any impurities from here into the aqueous layer, which we can discard. You will need a stopper, and it's always a 2-handed process. Now, I'm right-handed. I always hold the top of the separatory funnel with my right hand, ensuring that the stopper is in place. I invert. You might hear a small amount of pressure. Pressure will build up. The diethyl ether is quite volatile. It boils at 38 degrees. The warmth of my hand will cause pressure to build up. So, swirling, vent, swirling, vent, and after 2 or 3 times you can be quite aggressive. Letting it sit, you can see that the aqueous layer again sinks to the bottom, being more dense, and the aqueous, or the organic layer, diethyl ether, with our product rises to the top. It's hoped that any or most of the impurities that would be present here that are water soluble have now had a chance to get transferred into the aqueous phase and now reside here. So I'm going to put that into a secondary waste container. Take the lid off. If you try to drain the separatory funnel with the lid on, it'll appear to be clogged, but a vacuum just builds up and the liquid doesn't come out. So I remove the stopper. And drain the organic layer. And as the aqueous organic interface gets close to the spigot, I'm going to stop draining. Ensure I can leave a little bit of water. I just don't want to lose any of my organic material that's dissolved in the diethyl ether. All right, I'll do the extraction or the washing one more time. A lot of water. Cap, holding the cap securely. Vent. 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 And again, we can see that it settles pretty quickly. Diethyl ether is being a nice solvent to work with in an aqueous solution. Settles. And again, I can drain off the aqueous layer, which contains our impurities or salts. All right. Now what we're going to do is perform what I call a pre-drying step. I'm going to do this exact same process with brine. All brine is a saturated sodium chloride solution that is hypertonic and will pull moisture out of the organic layer into the aqueous layer. The diethyl ether layer here, containing our product, will actually dissolve a meaningful amount of water, up to 10% by volume. So though it seems to be one phase, we do know that water will be present. We have to remove that water. Initially, we start that process by a pre-drying or a brine wash. So again, I'm not going to measure an exact amount, I'm going to use an approximate amount, but the volumes I'm showing you are certainly approximate, but appropriate for this size flask. So we've added approximately 20 to 30 mils of brine to our separatory funnel. The two solutions have separated. The diethyl ether layer, the organic layer here, is at the top, and the aqueous brine solution is at the bottom. The difference is really quite subtle. If you gently agitate the separatory funnel, a keen eye can see where that interface exists. Now I'm just going to shake and as previous. Let the two solutions thoroughly mix. And hopefully with the air bubbles that are trapped at the interface, the difference or the differential between the diethyl ether layer and the aqueous phase is obvious. I'm going to drain the brine solution into my waste container. I'll do it slowly and hopefully the camera can pick up the moving of the interface between the organic layer and the aqueous layer. Faster. And we can see as it sort of moves down, the reflection, the way the light behaves with it becomes a little bit more obvious. And there we go. We've drained out the brine solution, now we just have the diethyl ether, our product, and still a small trace amount of water is likely present. That's a solvent-solvent extraction and washing.